In this video, we'll discuss solving radical equations. The first thing we want to do is isolate the radical to one side of the equation. If there's two radicals, we'll make sure they're on opposite sides of the equal sign. We want to raise both sides to the nth root, so whatever the root is. So if we got a square root, we're going to raise to the second power. If we got a third root, cubed root, we're going to raise to the third power, and so on. We're going to solve the equation left over because at that point, all of the roots should be gone. And then the solutions we get are just proposed solutions or possible solutions. So we want to check those and make sure that those actually do work. On part A here, we need to get the radical by itself. So we're going to subtract 7 from both sides. We get the square root of a plus 5 is equal to 5. We want to square both sides. The square and the square root cancel or undo each other. So we get a plus 5 is equal to 25. And then we subtract 5 from both sides. So a equals 20 is a proposed solution. We need to check and make sure that works. So we plug 20 back in. 20 plus 5 is 25. The square root of 25 is 5. And 5 plus 7 does equal 12. So a equals 20. Checks out. Part B, we subtract 4 from both sides. We get the square root of h plus 1 is equal to 10. We square both sides. The square and the square root undo each other. H plus 1 is equal to 100. We subtract 1 from both sides and we get h equals 99. At that point, we would plug 99 back in. 99 plus 1 is 100. The square root of 100 is 10, and 10 plus 4 is 14, so 99 checks out. All right, part C, we got a multi-step equation here. We got to get rid of the 12 and the negative 3. It doesn't matter what order we do those, so we're going to move the 12 first. Negative 3 times the square root of x plus 5 is equal to negative 9. The negative 3 is being multiplied by the radical, so we need to make sure we divide here and not actually add. We get the square root of x plus 5 is equal to positive 3. We square both sides. We get x plus 5 equals 9. And subtract 5 from both sides to get x equals 4. We plug 4 back in. 4 plus 5 is 9. The square root of 9 is 3. 3 times negative 3 is negative 9. And negative 9 plus 12 is positive 3. So x equals 4. Checks out. All right, our last equation here brings up a couple ideas. We subtract 5 from both sides. We get the square root of c minus 3 is equal to negative 1. We're talking about the principal square root here, and there's no way a principal square root, which is only the positive square root answer, could be a negative number. So at that point, we would know that this would be no solution at this point. However, if we continue to solve this, like we solved all the others, we would square both sides. We get c minus 3 equals positive 1. We add 3 to both sides, and we get c equals 4. If we plug 4 back into the original equation, we get 4 minus 3, which is 1, and the square root of 1 is 1. And 1 plus 5 is 6, and 6 does not equal 4. Therefore, c equals 4 would be this idea that we call extraneous solution. If this were a multiple choice test, we would pick the choice no solution, because 4 doesn't work.